Good morning, good evening, good afternoon, depending on where you are. Today is June 23rd. My name is Mati, and I'll be your host today. And this is another of our bi-weekly worker batch calls. Uh, Quick announcement, the cap freeze is later today. So if you have any last minute caps, make sure to grab your reviewers and PRR approvers and get them done within the next couple of hours. I can't remember the exact hour, but I remember it's halfway through my Polish night. So, with that out of the way, we have William, who will be giving us Volcano overview. So, take it away from here, William.
Okay, can you hear me?
Yep, loud and clear.
Yeah, sounds great. Let me share my screen. Okay, so I prepared material to show overview about the volcano. So uh, let's get started. So my name is William Wang, and I'm volcano maintainer, and it's my pleasure to share my practice in the last few years on cognitive batch system. Here is the agenda. I first introduce challenges we were facing on Kubernetes batch, and then I'd like to talk about Volcano, and later I'm gonna show some use cases in of customers, and last one is about the community. So here is a background about why we would like to have Volcano project. At the very beginning, we built a batch system for traditional HPC workload, and then we had a big data platform to handle the data-intensive analysis workload. And after that, we leverage cognitive technology for AI workload. But the major problem is that all these platforms are using different technical stacks, building different ecosystems, which make it hard to share resources between these different kind of workloads. And our resource utilization is low than expected. And maintaining multiple technical stacks at the same time takes a lot of costs and effort. So more and more organizations were leveraging cognitive technology to build a unified platform for our workloads. But there are still some gaps in cognitive ecosystem to support a batch. So we built KubeBatch in 2017 and to handle the scheduling gap. And then we built the Volcano based on the KubeBatch to deal with other gaps like performance and the job management. So here are some major gaps in cognitive ecosystem for batch workload. So the first one is about the job management. It's a common requirement to have different pod template and fine-grained lifecycle management in a job. And the second gap is about the scheduling, such as the job-based priority, the preemption, resource reservation, backfill, topology, and so on. And the third gap is about the CRD. So support different workloads in common job of CRD to reduce the complexity and the maintenance effort. As we know, there are too many CRD so far. The such as the MPI operator, PyTorch operator, TF operator. Uh, it's a big effort for customer to maintain so many operators and each operator have its its unique, have its characters which is different from each other. And last one is about the performance and the dynamic resource sharing. So most of batch workload requires higher throughput demanding. And for example, we got a requirement from our customer to dispatch 8,000 pods per second for Spark job, but currently the for the default scheduler, it only can dispatch about 100 pod per second. So, that's why we started the Volcano project several years ago. And here is the overview of Volcano. Volcano includes several components. For multi-cloud scenario, we have federation sub-project in pipeline to balance resource between different clusters. And in each individual cluster, we introduce several CRDs, such as job for common batch workload, and the queue for resource sharing, and the controller to help manage the life cycle of these CRDs. And the Volcano scheduler, VC scheduler, provide rich advanced scheduling policies and performance enhancement, especially to help those batch workload better running on top of Kubernetes. And from the graph, we can see Volcano engaged deeply with upstream computing framework like Spark, Flink, TensorFlow. So far, we have supported almost all of the popular mainstream framework. So Volcano is open source, was open sourced at 2019 and then donated to CNCF in 2020. This year, it was promoted to incubator project. And currently, there are more than 350 contributors in the community, and more than 50 enterprise users adopt Volcano in their production environment. So as we know, in batch system, there are several concepts which are important to the high-level design. The first concept is the job. For batch system, it's usually have common job specification for all kinds of workloads, such as AI, uh, big data, and so on. In cloud native ecosystem, it's required to introduce multiple templates and fine-grained error handling. The second one is about the tenants. Traditionally, batch system introduce user as a tenant, and Kubernetes use namespace as tenant based on my understand. And in order to avoid system overloading, resource limits is required to the batch system. For example, the Slurm has job queue quality of service, and Kubernetes supports quota to control how many resources can be created in system for each tenant. So last one is about the queue. Queue is common concept in batch system, and it is widely used in batch systems such as Slurm, ER, LSF. It has administrator to manage resource in cluster and share resources between these different tenants. In addition, some system support different scheduling configuration for each queue. It is useful feature for users. Uh, so in the following slides, I'm going to introduce the detail of Volcano. The first section is about the job management. In Volcano, we introduce the, a common job CRD with multiple pod templates as common specification to support all kinds of workload. Currently, we already verified several types of workload in production environment, such as MPI, TensorFlow, PyTorch, Hello, Cromwell, and here is an example about the MPI. The MPI master and the worker are using different pod templates with different command line and different resource requests. We can also support fine-grained lifecycle management. For example, we can restart the whole job when one task in the job fails. We also build job plugin to help user to customize enhancement. For example, the SSH plugin is used to configure SSH automatically for MPI job, and the service plugin is used to create a headless service for communication between the pods in each job. As we know, queue is common concept in batch system. It is used to share resource between different tenants. In Volcano, we follow this practice to make a queue in cluster level. So queue share resources between multi-tenants, and the quota is considered as a resource limit of tenants. Currently, Volcano support the first in, first out fairness priority algorithms for the queue, and the configuration is global for all queues. So we are also going to support configuration per queue for users. Here is another example showing how to share resources between queues. Suppose we have 6 CPU in the cluster and 2 queues. One queue is Q1, the other one is Q2, which is mapping 2 teams. The weight are 2 and 1 accordingly. At the beginning, in the Q1 and at the beginning, we submit one job with 6 pod in Q1, and the Q2 is empty. According to the proportion algorithm, the pod in Q1 is able to borrow resources from the Q2 to get all the pod running. And then we submit a new job to Q2. The scheduler will reclaim 2 CPU from Q1 based on the weight of them. So the new job in Q2 gather 2 CPUs and get running. In addition, we support guaranteed resource in queue for high priority jobs and support the capacity to avoid the system overloading. The next one is about the fair share scenario. Fair share is a common requirement for elastic or streaming jobs like Spark Flink. However, in Kubernetes, the more pods submitted, the more possibility to get more resources. There's no fair share. And we cannot pros the fair share between jobs and namespace for user. So we can see from the graph that user 1 and user 2 submit small job and big job to the same queue. The small job might get starving without fairness scheduling. So we cannot ensures big job and small job get resources fairly with DRF agrees. But only job fair share is not enough. Suppose one namespace oversubmits a lot of jobs to the queue compared to other namespaces, it would possibly occupy most of the queue resources. So we add the namespace level fair share in Volcano. As the graph shows, although the namespace 3 submit more jobs than namespace 2, but they get the same amount of resources individually. This is important in a multi-tenant environment for customer. And here are some scheduling policies in Volcano, and I will take I will show some part of them in the slides. So the one is about the elastic training scenario. Machine learning workload has higher demand for GPU compared to traditional workloads. So GPU is expensive resource. How to improve the GPU utilization is a hot topic and have great value. Elastic training can dynamically adjust the number of instances involved in the training. And so greatly improving the utilization of GPU resources, especially on the public cloud. It can work with spot instance to get a lower cost and improve the training progress. Firstly, let's say what elastic job is like. The left figure shows a volcano job. The mean available shows infers to the job which has 5 pod at least, and the replicas infers to the pod. The job has 10 pods at most. The job gets running where 5 pods get allocated, and then the job will extend more pods if there's more free GPU resources. Here is another scenario. As you know, the inference service always have a lower GPU utilization compared to the training workload, as people tend to collocate the inference service with the training workload to improve the overall utilization. The red figure shows an example. The inference job 2 with high priority preempt elastic pod from training job 1 to ensure its SLE. Whenever there's free resource available, the job 1 will extend more pods to accelerate the training. Here is another useful uh, uh, policy for user. This page shows how the task topology and IO awareness helps the distributing training. For some GPU training cases, the data exchange between tasks costs a lot of time and becomes the bottleneck of the training in our performance test. If the time of the data exchange could be reduced, the training performance can be improved. The task topology would schedule the PS and worker on the same node to reduce the data exchange latency. We also had the test with the default scheduler. There are 3 nodes in the test cluster, and we submit training job with 2 PS and 4 workers. We got three different placements at last. The results are random with default scheduler. As you know, the group C is the best placement that we want. With the task topology scheduling, we are able to get stable result as group C. As far as I know, some users use the affinity and anti-affinity features to achieve this goal. However, in our test, the complexity increases with this cluster scale, and the performance is not so good enough. We also do some research on the IO awareness scheduling. With the task topology info and IO information, we can minimalize the max data transfer latency and get even better performance for some kind of models. This figure shows the VGG16 model training results with default scheduler, task topology, and IO awareness scheduling. The IO awareness scheduling gets a 30% performance increase compared with default scheduler, and the result depends on the results depends on the data exchange and the models. So in a real production cluster, user often submit multiple kind of workload. For example, the small job and the big job. How to avoid the big job or small job get starving is very important. So the traditionally HPC system usually support this kind of feature, but in Kubernetes, there's no kind of capability. The left figure shows an example. At the moment of T1, user submit a big job with gun and a small job 2. The small job get allocated and big job 1 keep pending due to the insufficient resource. At the moment T2, a new small job 3 was submitted and get allocated. The big job 1 keep pending. With the time goes on, the big job will get starving if the released resources always cannot satisfy is gone, and user submit some small job continuously. So the SLA scheduling algorithm allows user to configure the job so that it is completed on time to reduce the risk of missed deadlines. SLA waiting time is the maximal time that one job should stay in pending. When SLA waiting time reached, the SLA plugin in Volcano moves the pending job to the next state and start to reserve or hold resources for this job until the job's request is satisfied. Spark starts to provide support in, in Spark 2.3 version in 2017. And later, Spark Operator provides another way to help run Spark on Kubernetes as well. However, in a very long time, Spark on Kubernetes lacks of batch scheduling abilities. So late last year, we started to work with Spark contributor to support customer masked batch scheduler for Spark. And Spark with Volcano provides the common batch scheduling abilities like job-based priority queue, file share, resource reservation, and so on. And it has been released in Spark 3.3 this week, uh, and user can use Spark 3.3 with Volcano to enable the batch scheduling policies. As this another use case in Huawei Cloud, as the amount of data continues to grow and the complexity of business increase. Our users required Kubernetes cluster support larger scale. So we also spend lot of effort to support 10,000 nodes and 1 million cluster 1 million cluster by optimizing the container network scheduling, container engine, etcd, and API server. The red part lists some specific approaches. Take a scheduler, for example, we improve the scheduling throughput to 1.5 thousand pod per second by adopt the equivalence cache, batch binding, and async binding, and code level code level optimizing. So here I will show several use cases uh, for Kubernetes and Volcano. So Xiaohongshu is one of the top social media and e-commerce company in China. Many people use their apps in mobile phone, and they have 1 million active users per month. And the main workload they are running is to provide recommendation for end users. They need to refresh the model every several minutes, and they have some online service to do immediately reaction when user refresh their nodes. So the challenge is they have large cluster with nearly 2,000 nodes, and the model have 100 million parameters. One TensorFlow job has more than hundreds of PS and worker code. Actually, they want the best resource allocation and utilization. So the user adopts the task topology scheduling and gain the around 20% performance increased. And they also use the SRE-based scheduling to prevent large job from starving. Another case is about the financial sector user. They initially use the Hadoop ER to schedule the batch jobs, and the company grows. The environmental policy also changed. Different research team require container deployment to avoid the environmental confliction and dependency. So, however, the Kubernetes default scheduler like lacks fair share scheduling between multiple teams. So they have a requirement of using different frameworks such as they also have the requirement of using different framework such as TensorFlow, PyTorch, and MPI. That that requires to install different kind of operators in their environment, which leading high cost maintenance and the learning because they are a faster they are a small faster starting company. And the user looks for the solution and found Volcano can satisfy their environment, their requirements, and offer diverse scheduling abilities. And what's more, and they could use Volcano job to unify the TensorFlow, PyTorch, and MPI jobs. Eventually, they decide to migrate it from the YAR to Kubernetes and Volcano. Now Volcano supports about 300,000 posts increase per day in their production environment. So for the public adoption, we do get a lot of users adoption, especially for people who are running the AI big data, gene transcoding workload on Kubernetes. Here are some parts of the adopters using Volcano in production environment. For the code diversity in recent years, you can find that we get a good diversity in community development, almost more than 50% contributors are from the community members. So here is the release journey of Volcano. We have released more than 16 major versions since open sourced. At the early age, we developed a set of scheduling policies to support batch workload, and then integrate with ecosystems such as Kubeflow, Spark Operator, Flink Operator, Argo, Manuscore, PadPadle, and so on. And then we found that there's a lot of gaps in the job management. So we spent quite a lot of time to enhance the job management to deeply support upstream computing framework. And in the
William,
future,
sorry to interrupt you. We are halfway, well, two-thirds through our reserved time, and I would like to use the remaining 15 minutes for the questions.
oh,
Do you have
okay.
do you have many more slides that you want to go through?
Okay, this is the last one,
Okay, okay,
last
okay,
page.
cool,
Yeah,
perfect.
maybe, yeah.
Okay, if you don't have any further closing comments, Abdullah, you had your hand raised for quite a while. Go ahead.
Um, thanks. This was like really great, rundown of the Volcano ecosystem. I have a couple of questions. I'll start with one related to the job API. You mentioned that you have multiple components in Volcano, which is like the scheduler, the job like management, and whatnot. I'm wondering like if Volcano has been like started like, I don't know, in 2017, 3-4 years ago. I was wondering, why didn't you think about improving the existing job API to satisfy your needs? Like within the next, like in 3-4 years, I would imagine by now, like the job API could have evolved to fix all these gaps that you've noted earlier in the journey. It's easy to ask this question now in retrospect, but I'm wondering if you have any thoughts that you still believe, like, for example, the core Kubernetes job API wouldn't, evolve to fix all these gaps.
So for the job management, I think the biggest gap is the multiple pod template, uh, because for the batch workload, most of the batch workload have several roles in one job. Uh, for example, the Spark, they have driver and executor. For the Flink, they have job management pod and task management pod. For the TensorFlow, they have PS pod, worker pod. So pod template is very important. Without multiple pod template, we cannot consolidate to all those different kind of workload.
Right, but like, was this proposed, for example, to the Kate's community and was rejected? Like, for example, I imagine like a V2 job API that includes multiple templates, like to fix this gap. It's just like my concern here is that, again, like with introducing a new job API, like if you had invested in the core Kubernetes job API, you might have gotten like more traction with Volcano, because it will be easier for users to, migrate to use Volcano without changing too much and without being concerned about, fitting their workload for a yet another custom API. But I totally get, like, if you have a concern about like velocity, how fast we can iterate over it. It's just like I was like, because you started like 3-4 years ago. It's tempting to ask this question. Oh, if we had started 3-4 years ago improving the Java API, by this time we would have had all these gaps fixed. But yeah.
Yes, it's a very important to it's a very important. So far I have no idea about the decision. I don't know the upstream the Kubernetes the strategy with the other CRD. So in the early time, we want Kubernetes to support the batch job API, and at that time, maybe maybe in Kubernetes they want most of people want the job API would be more lightweight, and the CRD use CRD to describe complex the job. So so far I have no idea about whether it's right to or it's a good choice to support all kind of this ability, like multiple templates in Kubernetes job v2 job API v2.
That is okay. I think I just hope that if we manage to evolve the job API to the stage where it fixes these gaps, maybe Volcano can migrate to use that common API. This could be like one way moving forward with this. My second high-level question about the scheduler, like it is, how do you keep updated with the new K8s features? Like, for example, wait for first consumer volumes. Those are like baked into the core Kubernetes scheduler. Or this new proposal, I don't know if you've been following it in Kubernetes, which is the dynamic resource allocation. This is a really complex proposal that involves many components, including the scheduler. Do you import any code from the core Kubernetes scheduler to achieve these, like, requirements? Similar things with like affinity and whatnot. I don't know if you re-implemented them yourself, or like Volcano, I mean, or you just import them from core Kubernetes.
Oh, that's a good question. The Kubernetes supports multiple scheduler. So in Volcano, Volcano just import the default the scheduler framework package and use the use the import to import the default scheduler ability in Volcano to support the affinity, the toleration, and all these policies.
All right, thanks.
Does anyone else have any questions for William?
Hi, so I have a question. So you mentioned federation and sort of sharing workload between multiple Kubernetes clusters. Can you please elaborate on this slightly?
Yeah. Yeah, the uh, uh, we have plan for the volcano federation to balance resource among different clusters, and this feature will be ready in the this year. And we also found that there are already several multiple cluster project like Commanda, like other project, but all these projects are aims to provide the HA for the microservice. So our community users always have multiple clusters in their environment. So a lot of users require the volcano federation ability.
So perhaps you could also comment on the relationship between Volcano and something like Armada.
Amanda, yeah, Amanda. Currently, I just I know little about the Amanda. Amanda, some of users use Amanda. Maybe I haven't have a deep investigation and comparison so far. Maybe in a later time I will maybe after the investigation I will I will show you about the difference.
Right. Okay, so I have one more question. So do you, so one of the worries with something like Volcano, to me at least, would be load on etcd. So it seems like you have lots of jobs and you have a system that sort of fundamentally has a lot of interaction with etcd by creating these custom resource definitions and so on. I'd be a bit concerned about etcd falling over when you have high throughput. Is this something that you've had issues with?
Pardon? I didn't catch you.
So I was just wondering if you could comment on potential issues with high load on etcd from a system like Volcano.
I'm sorry.
Yeah, no worries if you don't haven't looked into this. I was just curious.
I'm
Aldo,
sorry.
you had your raise. Okay, Aldo, you wanted to ask a question.
Yes. So a common complaint I've heard from customers about Volcano is about its interactions with a cluster autoscaler. Um, do you have any plans to solve this issue, or like do you plan to also fork cluster autoscaler? What are your thoughts on autoscaling?
Sorry.
I'm wondering what are your long-term plans for auto-scaling, cluster
Auto
auto-scaling?
scaling. Yeah. Auto scaling is a big problem for us. Our basic idea is we have planned to, because the auto scaling and the scheduler, they have a relationship to achieve a better a better a, a better result, but not right now they are separated. So we have a plan and a basic idea, but it's not mature. The basic idea is we might create a CRD to 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 connect the auto scaling and the scheduler. They use the CRD to communicate the the detailed information to make the scheduling more intelligent. But so far, I have no detailed idea. Uh,
It, it would be good if that you can bring that idea once you have it, because I think it would be a very bad thing if you end up forking, let's say, cluster autoscaler, um, because then it's harder for people to migrate, to maintain two systems and so on and so forth. Um, so yeah, that would be my request.
yes, so far we fork autoscaler and uh, do some enhancement internally. Uh, mm, we ever submit some patch to upstream, uh, but it's sometimes it can't it has a long duration to merge the PR. So just right now we just fork autoscaler.
Swati, you had your hand up.
Yeah. So in the presentation, I noticed that you mentioned Volcano supports scheduling policies, and one of them is NUMA awareness. I'm just curious, how is that support enabled for batch workloads in, say, Kubernetes? And one of the reason I'm asking that is because we've been working on enabling NUMA awareness in Kubernetes. So, like, is there something we need to converge those efforts? Is there dependency? Is there reuse of some of the work that we had been doing? Or is there something we should be doing to reuse some of the work that you've been doing in this area?
Yes, it's a good question. For the NUMA aware scheduling, in the last year, one of our customer wants this feature, so we communicate with is the the community, the Kubernetes community. The developer said it's a long-term feature and cannot meet of deadline. So we started to support NUMA aware scheduling in Volcano. So currently, it's a good idea to whether we can to merge or do something to keep the Kubernetes NUMA aware scheduling and the Volcano NUMA aware scheduling to reuse to have a good user experience for our user.
In terms of, like, if you can point us to like some of the code that has been done to implement that in Volcano, we can take a look, because I'd be curious to see like how the APIs look like, and if there's something that maybe we need to take into consideration when we are enabling NUMA awareness in Kubernetes natively.
Yeah, sure. Sure. We can make a meeting and 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 talk in that meeting for some detail about
Cool.
the pneumaware.
Cool. Sounds good. Thanks, William.
Okay, Arpit, you
Yeah,
have one more
uh,
question.
I do have a
And I'll
question.
mute all.
So for Volcano, did you do any kind of benchmarking, which means that publish number, hey, this can support this many job bursts or for this cluster size, so that we can have an idea at what is the scalability limit and yeah.
Benchmark, we test we test for the scheduling policies, several scheduling policies, just like minimal resource reservation for Spark, for the performance increase, and we test for each important scheduling policies for the performance improved, and also the scheduling throughput. But we don't have a complete benchmark to test uh, all the all these what you just said.
Got it. Got it. So the job burst and then all that and all this. Another question is that you mentioned in one of the slides is that the max cluster is 10K nodes. So is that 10K node like 10,000 nodes are in one cluster, or they are spread across multiple cluster and you federated them?
Sorry, I didn't catch you.
Okay. So in one of the slide, I remember seeing that the max node tested are 10,000 nodes and 1 million pods. So I was just wondering, are those 10,000 nodes are part of one Kubernetes cluster or multiple Kubernetes cluster?
Uh, 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 it's one Kubernetes cluster, and in Huawei Kubernetes cluster.
Okay.
Yeah, yeah. We do some enhancement. Some of the enhancement we want to submit the PR to Kubernetes. And it's in our pipeline to submit the PR. For example, the batch bound API, it is very useful to improve the scheduling throughput.
Got. Thank you.
Okay, thank you very much, all. Sorry for taking extra 5 minutes above the usual time. Thank you very much, William, for presenting the volcano, and see you all in 2 weeks. Bye, all.